Hello, I'm here ready to tell you about barometer versus manometer. A barometer is a scientific instrument used to measure air pressure. We have two types of barometer, which is mercury and aneroid. What is air pressure? If you have ever been scuba diving, you will know just what pressure feels like. Dive down beneath the surface on the sea and you will soon feel the weight of water pressing in on you. The deeper you go, the more water there is above you, the more it weighs and the more pressure you feel. Look up at the sky and try to imagine the weight of the atmosphere, the huge amount of gas surrounding our planet and pulled to its surface by gravity. All that gas might look like a vast, empty cloud of nothing, but it still has weight, and it still presses down on your body. That's air pressure. Pressure tendency can forecast short-term changes in the weather. A mercury barometer is a 30-inch glass tube, which is sealed at one end and open at the other. The tube is filled with mercury at the base and placed upside down in a container called the reservoir. It works by balancing the weight of mercury within the glass tube with the atmospheric pressure. When the weight of mercury is less than the atmospheric pressure, there is a significant rise in the mercury level in the glass tube. Similarly, when the weight of mercury exceeds the weight of atmospheric pressure, there is a fall in the mercury level. A non-liquid barometer called the aneroid barometer is widely used in portable instruments and in aircraft altimeters because of its smaller size and convenience. An aneroid barometer consists of a small flexible meter box called the aneroid cell. It is made from an alloy of copper and beryllium. This cell is supported by a strong spring to prevent it from collapsing. Even minute changes in the external air pressure cause it to expand or contract. This expansion and contraction triggers the mechanical levers, as a result of which tiny movements of the cells are amplified and displayed. A manually set needle is used to mark the recent measurement so that the change doesn't go unobserved. A manometer is a tube-like device which measures atmospheric pressure. There are two types, closed tube and open tube. A manometer is comprised of a bulb containing a gas and a U-shaped tube. The U-shaped tube is partially filled with mercury. When gas pressure is greater than atmospheric pressure, the mercury is pushed toward the open end. When gas pressure is less than atmospheric pressure, the mercury is pushed toward the gas reservoir. The difference between the heights of the mercury on each side of the tube is a measure of the pressure of the gas. Depending on the pressure of the contained gas, the mercury shifts. Probably, the most familiar example of a manometer is a manometer, which is used to measure blood pressure. The differences of barometer and manometer in shape and design and their functions. First, we go to shape and design for barometer. This is traditional barometer that has a glass tube with one open end and a vacuum at the end of tube. Then, shape and design manometer. The simplest kind of manometer is the U-tube. One end of the U-tube is connected to the pressure that is to be measured, while the other end is left open to the atmosphere. Finally, we move to the last difference of barometer and manometer. Function of barometer is to measure the atmospheric pressure. Meanwhile, manometer to measure pressure of other gases, since U-tube can connect it to the other gases. A differential manometer is connected at 2 points A and B as shown in figure. At B, air pressure is 9.81 Newton per centimeter cube. Find absolute pressure at point A. From these figures, there are two different pipes, which is pipe A and pipe B. On the left side, we have an oil which is specific gravity is 0.9. On the right side, we have water. Next, we have mercury whose specific gravity of mercury is 13.6. Now, this is the data that we have. Okay, the question is to find the absolute pressure at point A. It means you have to find the pressure at oil. In the left limb, we have the height of the mercury which is 10 centimeters. Since the specific gravity of oil is given which is 0.9, so the density of oil is 900 because 0.9 is multiplied by 1000. So we can calculate the values and get PA plus 13,341.6 plus 1,765.8. This is the equation 1. Now, total pressure in the right limb, we also use the same formula which is rho for the water and gravity. So, we have the pressure of air given which is 9.81 times to 10 to the power of 4 plus the rho of water which is 1000 times with the gravity 9.81 and 0.9 and 0.6 which is the height of the limb. So we get 1.04 times to 10 to the power of 4. This is the equation 2. Now I equate the value by equating equation 1 and equation 2. So PA plus 13,341.6 plus 1,765.8 equal to 1.04 times to 10 to the power of 4. So we shift the value to the right so we can get the absolute pressure at point A which is 88.88 times 10 to the power of 3 Newton per meter squared. So this is the answer for the pressure at point A.